Happy Valentine's Day, everyone. Anybody have any questions before we start? Okay, just some news. The School of Computer Science has 10 PhD studentships. So if you're thinking about writing a PhD in computer science and you want to get paid for doing so, like a job, you're welcome to apply for one of those studentships. And you can come and talk to me, right? We have a visualization and graphics group. So if you're interested in visualization and graphics, you can come and talk to me. I've put a link to that advertisement in our Teams chat. So research methods, this module has a Teams chat, and I've put a link to it in there. Any questions about that? Anybody ever thought about writing a PhD before? Nice. Okay. If there are any questions, feel free to interrupt at any time or make any comments at any time. So today's lecture is an important one. You will need to understand this lecture to succeed in coursework 1. And then coursework 3 builds on coursework 1. And then the rest of your life builds on courseworks 1 and 3. So today you really want to pay attention. We're going to talk about a special skill, how to read a computer science research paper. And it's a very special skill. And it's very difficult, actually. Yeah, it's a very difficult skill. Like, it takes practice. And we're going to develop that in this module, right? So usually when you start a new project, you perform some sort of literature review, right? And that literature review is to find out who has worked on that problem that you're considering and what did they do, right? When you look at these research papers, though, you get a little shock, right? Has anybody tried to read a research paper before? Has anybody tried this yet? You might have noticed it's difficult. Anybody notice that it's difficult? Yes. They're complicated, right? A single paper can be very complicated. It might have a detailed mathematical framework. It might have complicated algorithms and techniques, complicated data analysis. Each paper is generally the result of multiple man-years written by experts. So you see a list of authors on the paper. Usually they have put at least a year each, at least, into that paper. A year into 8 to 10 pages, right? And that's a minimum. It might be 2 years, it might be 3 years. Like 3 people putting 3 years into a paper, not very uncommon. That's 9 man-years of effort put into this paper. So, and there's a very large volume of previous literature, right? There are millions and millions of papers published every second. But there have been so many papers published. So it's really, really difficult to navigate this landscape due to the volume. So you have complexity and you have volume combined. These are the challenges you're facing. So keeping up with the literature explosion is commonly identified as one of the top unsolved problems in any field, in any field, right? So the question is, how can we navigate through this massive volume and complexity? Is there anything we can do about this? That's what today's lecture is about. This is one strategy. It's not like it doesn't solve all of your problems, but at least it provides one solution as opposed to zero, right? One solution is a lot better than zero. And it's a very special technique. It's one that's only taught at this university. It's not taught anywhere else in the world. So we're just going to, this is a little bit of an overview of today's lecture. So we start with a motivation and introduction. Actually, we're going to skip, there has been some related work in this area that we're going to skip. If you want to see the related work in this area, you can look at a research paper called How to Read a Visualization Research Paper. You'll see a reference to it at the end of the lecture, and there you have a related work section. We're going to describe this. This is a central principle, concept versus implementation. To succeed in this exercise, you have to introduce the notions of concept and implementation and decouple them. You have to separate them. That's part of the skill, to get these two things separated in your mind, because they're distinct. They're related, but they're separate and distinct. They're not the same. They're related. And then we're going to look at what we mean by extracting the essentials of a computer science research paper. And we're going to provide some examples of that process, or the results, let's say. The results. It's going to be difficult. I'm not going to advertise that this is easy. No, I'm not going to advertise this is difficult. This is a difficult skill. Not many people have this skill, right? But if you can develop this skill, you will escalate yourself into a special category of let's say, education that is, in the top 10th percentile of the entire world's population. Okay, so some of the principles. When you look at a research paper, one of the important things to know is you don't need all the details. Not all the details are essential, right? So if you look at it, the research paper as a bunch of words or a bunch of figures or a bunch of equations, some are more important than others. Not all of it is the same importance. So our goal for this skill, developing this skill, is for writing a literature review. We want to write a literature review that addresses the previous literature on a given topic, right? These have different names: literature review, literature survey, or state-of-the-art report. They all mean similar or almost the same. Might not be exactly the same, but they're all very, very similar. And why do we write literature reviews? So literature surveys or reviews are a good way to obtain an overview of the literature and find solved and unsolved problems. Right? Research is usually trying to solve unsolved problems. That's usually what we're trying to do, right? That's a contribution to science, right? Introducing a new solution into the world that didn't previously exist. And so this strategy that we've developed is based on experience and writing several survey papers and literature reviews. And this is very good for people writing their master's degree or PhD. But you know what? This skill is very valuable for after you graduate too. If you're interested in learning about any subject, this is a very valuable skill. Like when I apply this skill into other areas, like if I'm interested in health, I will look at the research papers on health, right? I do that all the time. I'm not a health expert, but I can pick up any health or medical research paper and I can extract the essentials from them and get the information I need, right? That's a really valuable skill. So if I want to educate myself on any topic, you know, if somebody tells me, oh, this is true, and I want to find out if it really is true, I can look at the research literature and find out if what the person is saying is really true or not. It's a very, very unusual skill. It's really unusual, and you can develop this skill, you can have this skill after today's lecture. So it starts, if we want to develop this skill, we have to separate these two ideas. One's called a concept and one's called an implementation. Two words, two different ideas, but they're closely related to each other. They're just not the same. So if I look up the word concept in the dictionary, I will get a general notion or idea, a conception, an idea of something formed by mentally combining all its characteristics or particulars, a construct. Or 3, a direct, conceived, or intuited object of thought. That's from dictionary.com. You can look up your favorite definition in your favorite dictionary. But the point is, a concept is an idea, and it's abstract, and it's in your head. It's in your imagination. Right? It doesn't actually exist in reality. It's in your imagination. It's not, you don't see that concept necessarily out in the real world. It's not floating in physical space anywhere. It's in your imagination. Right? You conceive something. Then implementation. The act of accomplishing some aim or executing some order. The act of implementing, providing a practical means for accomplishing something, carrying into effect. So an implementation is something real, it's something tangible, it's something that you can measure, that you can see and observe in the real world. Does that make sense? This isn't, so far, I hope you're with me, like, it's not complicated, I'm not trying, there's no trick here. Right? This is hopefully something that makes sense to you. So a concept is an idea or a thought. Good luck trying to define what a thought is, by the way. I don't think anybody has a good definition of what a thought is. Anyways, let's not go there. A concept is an idea or a thought. A concept is abstract, not something with mass that can be weighed on a scale. I don't know if that even helps. But it's in your mind, a concept or a thought or an idea. It's very abstract. An implementation is you could call it the physicalization of an idea or a concept. An implementation is a concept that's been brought into reality. Like you've had this idea, and then you actually implement the idea. You've taken that idea that was existing in somebody's mind, or multiple people's minds, and then you've brought it into reality. Like, oh, I have this idea. I'm going to create a movie based on a bunch of toys, right? And bring these toys to life. That's an idea. That's an idea, it's a concept. And then somebody came along and said, oh, I'm going to implement this idea. I'm going to make this idea into a reality, and I'm going to publish a film called Toy Story. Right? That's the implementation of that idea. Does that make sense? Have I lost anybody? So for this lecture to succeed, you have to be able to separate these two things, concept versus implementation. By the way, this separation, this realization that these two things are different is very, very confusing to the general populace. When you talk to the general populace, they have these two things mixed up in their mind. So just being able to separate these two things in your mind is already a special skill that most of the general populace does not have. So a concept starts out as an idea in someone's mind. This is just more about concepts. A concept is often written down on paper. So somebody might have an idea and they think, oh, I don't want to forget that. And they write the idea down on paper. Right? And that idea might be a hypothesis or a specification. Right? Like, I bet, like I might have this idea, I bet that if I developed a story based on toys and turning them into characters, that would be a huge success. That's a hypothesis. I bet this. If this happened, this would be a huge success. That's a hypothesis. Right? And then a concept is implemented. The next stage is to turn that idea into a reality. Right? That's the implementation. And then, so it often is formulated in this kind of conversation. I have an idea. Okay, how are you going to do it? How are you going to bring this idea into reality? I mean, another common example is a business, right? I have this business idea that I think that I can sell books online and it will be a big success, right? And then somebody created Amazon.com. That was the implementation of that idea. And it turned out to be a big success. So Jeff Bezos had a hypothesis. He had an idea. Oh, I think if I sell books online, that's how Amazon started. Did anybody know that? Who knew that? Anybody? Nice, nice. That's how it started, right? He had a hypothesis. I think that if I sell books online, it's going to be a big success. That's a hypothesis. And then the question is, oh my gosh, how are we going to turn that idea or concept, how are we going to implement it? Right? Those are two separate things. So just another example, a writing utensil. Right, a writing utensil is a tool with which we can write something and communicate using symbols. That's an idea. Like somebody had this idea at some point and said, I bet we can communicate with symbols, right? And I bet we can create a tool to draw those symbols. Somebody had this idea at some point, right? It started out as an idea or a concept, and then one implementation is a pencil. Somebody said, okay, how can we make this a reality? Let's try to make a pencil, right? This little piece of wood with graphite in the middle, and we can rub the graphite on a surface and then draw symbols, right? That's the implementation of a writing utensil. So a pencil is a type of writing utensil, or more specifically, it is the implementation of a writing utensil, right? Somebody turned this into a reality. They developed a tool that implements the idea of writing or a writing utensil. It's not a very exciting example. Question?
I think generic concept is hard to do, and implementation is hard to do.
Yeah, I guess you can associate the word implementation with how to do something. And then a generic concept, you could associate that with what, possibly, like what to do, or I have this problem that I want to solve. It's usually a problem that you want to solve. That's usually what the concepts, how they're derived, right? It's usually kind of like mother is the necessity of invention. Wait, I said that wrong. Anyways, necessity is the mother of invention. Okay, it's a good thing I have that recorded. Anyways, that's the idea. Okay, to further illustrate this, for any given concept, there are an infinite number of potential implementations. So the mapping is one to many, from concept to implementations, right? There are other websites that sell books, right? You can get books from other websites, not just Amazon, like eBay, for example. There used to be a website called books.com. There used to be a website called half.com that sold books. That's gone out of business. But anyways, any concept can have many implementations. Many implementations. There's no limit, essentially. There are essentially an unlimited variety of different implementations of a writing utensil, right? How many different pens and pencils have you seen in your lifetime? Look, 1, 2, 3. Here are 1, 2, 3, 4, 5 different implementations of a writing utensil. None of these are the same, right? So this is something to keep in mind. For a given concept, there may be many different implementations, right? Another example could be a web browser. I have this idea of a web browser. There are several different implementations of web browsers, right? So Netscape, Internet Explorer, Opera, Google Chrome, Safari, right? There are several different implementations of phones. Right? So this is really important when reading or writing a research paper, as well as most other areas of your life that require critical thinking. If you can apply this outside of computer science. This doesn't stop in the research methods module. If you want, it's a choice, right? Or you can just carry on as if you never learned this and see the world in the old-fashioned way. It's fine too. So how does this apply to research papers? So we have concept and implementation. Are there any questions about concept versus implementation? Any questions about that? So,
we need ideal and entity in philosophy. Ideal and entity.
Ideal?
And entity.
An entity?
Yeah.
I don't know what entity refers to in philosophy, so I don't know.
Specific object.
If it's something that you can see and touch, then yes, it would be implementation is something. Implementation is something that you can see and touch. A concept, you can't see it or touch it, right? It's just in your imagination. Other questions or observations? So, that's not meant to be complicated. There's no trick there with concept and implementation. But it's probably the first time in your life somebody has told you there's a concept and there's an implementation, and they're not the same, and you need to separate them. You need to treat them as different. Right? They're not the same. So how does this apply to research papers? One of the essential elements of a research paper is the concept. What is the concept that this research paper is describing? The concept. We want to get the concept. This is one of the essential elements of a research paper. How can we look at a research paper and get that concept out? We need to get the concept. That's one of the essential elements, right? And that takes a special skill. That's a special skill, right, that we're trying to develop. So when you look at a research paper, you're thinking conceptually, what are the authors trying to achieve? That's their concept. They're not going to say, this is our concept. It's not going to say that in the paper. But you can train your brain to extract the concept. What is the goal of the work? The authors might use that word goal, like the goal here is. What is the contribution of the paper? That's another term, this common term used in a research paper. This paper contributes the following. That is the concept that is directly related to the concept. Other terminology is what's new in the paper. What is the novelty? That is also directly related to the concept. So every research paper contributes something new. They're doing something new to push the barriers of knowledge, expand our knowledge, right? That's directly related to the concept. And then most of the paper is really about the implementation. How is this concept realized? How do the authors support their hypothesis? How do they implement their concept? This is what most of the words and the content are describing, right? So these are the essentials right here. These are the essentials on one slide. So when we have a research paper, we want to extract the concept, the implementation, the core related work, and the input data characteristics. These are 4 essential elements that we want to extract from any given research paper, and they're the essentials. And then the implication is we can leave out the rest. So we're getting these 4 pieces of very valuable information out, and then we're leaving the rest, right? There's usually a related work section. What previous work does this paper build on? Most research papers, if you look carefully, build on 1 or 2 previous papers that are core, like they're the most important. So we want to try to identify what the most important previously related work is from the selection. Usually there's 20 or 30 in a related work section, but usually you can identify 1 or 2 that are the most important from the rest. And then the input data characteristics. Usually, not always, but usually there's some data involved. In the world of computer science, we're usually using software. We're either using the software or developing the software ourselves. And software generally has data that it reads and processes. So what is that data? The whole experiment won't work unless we have this input data. What is this essential input data that we're processing? Right, in AI, right? AI is the big hot topic right now, right? And then we have this very, very popular class of AI algorithms called machine learning. What is the input data to machine learning algorithms? Anybody have any idea? Nobody's feeling brave enough to try to answer that question in the front of the class. The training data. the training, right? All these machine learning algorithms need training data. So that's the input data. So what are the characteristics of the data, the input data? Is it spatial? Is it two-dimensional? Is it geospatial? Is it three-dimensional? Is it temporal? Is it static or time-dependent? How big is it? Right? How big? So that's a huge theme. It's a very, very big theme. Is the data structured or unstructured? Is it abstract or scalar? Is it multivariate data? Right? Those are all questions that we want to extract from a research paper. Important questions. So coursework 1 is about developing this slide 9. Like, can you get this skill? Can you develop this skill? And that's what a template looks like. This is the template we're going to use when we do coursework 1 and when we extract the essentials of a research paper. We want a 1 or 2 sentence summary of the concept. We want a 1 or 2 sentences summary of the implementation. We want maybe 2 sentences, 1 or 2 sentences of correlated work. We want the input, a list of input data characteristics. We're also going to look at evaluation techniques and maybe other information that you think is essential. For example, a sample image from the paper is always nice to have one little image that is your favorite image from the paper that might help you jog your memory. And then, of course, like the URL to the PDF, for example, might be a good thing to have there. The citation information. So that's a template you can use. That's also in coursework 1. Any questions so far? Everybody feeling confident that they could succeed in this amazing skill? It's a great skill to have. It's really great. I'm very happy that I have this skill. Like, it's not like it's the key to happiness, but it's a great skill to have because I can look at any research paper and get the essentials out. And it doesn't have to be computer science. It can be medicine, it can be health, it can be finance, it can be physics, it can be geography, bioscience, mathematics. The same principles apply. The same thing. You can use this template across all research papers. And you can read them. You can get the essential information, the essential message out of them. Question?
So there are a lot of papers on one topic. So how do we decide which one is good or which one is not?
That's a different lecture. Thank you for asking that. We're going to talk about that in a different lecture. So this is just given, like you're just given a research paper. You're just like, here it is, it's in your face. It's in your face, it's this really complicated and intimidating thing. And then you're like, oh, how do I read this? What am I supposed to get out of this? What am I supposed to look for? Right, this is the questions we're answering today. Right, not that one. We will answer that one, by the way. If you can't wait, if you're just over exuberant, you can look at last year's recordings yeah, they won't be as good as this year's recordings, but yep.
The results are not included in this design solution.
Yeah, that's a good question. That's a good question. So this gentleman, what's your name?
Zach.
Zach pointed out the results are not included. Okay, that's true. There's nothing that says like results. However, there's an implicit results in the evaluation techniques. So I haven't talked about evaluation techniques yet, but inside the evaluation techniques, there's an implicit message. How did they demonstrate that they achieved their goal? That's in the evaluation techniques. So you can mention results in the evaluation techniques, which we're going to talk about. Another question?
I want to talk about the last slide. There's input data.
Yes, yes.
And how kind of data we should consider.
So that's one of the things you look for in the paper. You look, there'll be a section that describes the input data. In order to perform this experiment, we use the following data. Every research paper will have some sentences that describe the data they use to perform the experiment. And that's the data you're looking at and you're trying to describe yourself.
But some research paper, I'm not sure if they are belong to research paper. It don't have too much data, I think.
Every research paper will have a different set of data. That very rarely will it be the same. It's possible, but every different research paper, as a general principle, will have its own input data. It might be a very small data set. It could be very small, but it might be very large. So it's going to have, like, the number of different possibilities is unlimited. There's no limit to the different possibilities for the input data.
So this data is relevant to numbers.
Yep, it could be numbers. It's not always numbers. It could be images. It could be videos.
Example.
It could be, it might not be numbers. It could be text. Yep. Could be anything. Yeah. Could be sound. It's not just necessarily numbers per se. Other questions? We are going to go over examples. This is just the beginning, by the way. It's not the end. We're going to go over examples. Right, Friday's workshop, we're going to go over this some more. This is going to be a recurring theme. This is an essential skill of the research methods module. So it's going to be coming up over and over again. So you guys haven't seen this paper. You haven't seen it. It's just an example to give you an idea of what we're looking for. So this is a paper called Fast and Resolution Independent Line Integral Convolution. Right? It's a very complicated paper. It's difficult to understand. It's very specialized. Right? Even the title is just like, what? Huh? Like, what are you talking about? At least you can understand the word fast, though, right? Fast. This is an example of what I'm talking about. So I've taken this paper, and then I've applied this process of extracting the essentials from this research paper, and this is the result. This is the result, what we're looking at now. I've extracted the concept. This paper contributes a faster version of an algorithm called line integral convolution. It brings the original LIC algorithm towards interactive frame rates. Can everybody understand that? It's taking one algorithm and making it faster. That's the concept. It's a simple concept, actually. Here's an algorithm. I have an idea about how to make it faster. I'm going to publish that idea. So many papers are just this. Take a process, make it faster. Right? That's the concept. It's a simple concept, actually. Run faster. That's a simple idea. Right? Nothing too complicated. Okay, Implementation. This is where everything gets complicated, everybody gets lost, and they feel like jumping off a bridge, right? So most of a paper is about the implementation. The good news is we don't care that much about the implementation. We don't want to know the details of the implementation. We're going to leave that behind. We're not going to worry about that too much. We just want like 1 or 2 sentence summary of the implementation. So we're taking like 8 pages of the paper and we're summarizing it in 1 or 2 sentences, right? And that's a skill, and that's a skill we're going to develop, right? So I've just taken that 10 pages and I've summarized it in 2 sentences. They achieve this by reducing the number of redundant streamlined computations. You could have 1 sentence, just that 1 sentence. But of course, the details in the paper are much longer, right? But this is the essence of the implementation, the essence, like the key ingredient to the recipe, right? So like this is sort of the deciding factor here. It's like, this is the reason this whole thing works. It's because we've separated out the concept. That's really important. And then we've filtered out and left out all the implementation details. That's why this process works. And then I've gone through the related work section, and I've identified 1 paper that's really the core related work. They've taken 1 algorithm and they've made it faster. The related work has like 20 papers in it, right? They're all related. But really this is the core one. They've taken this one and they made it faster. And what does the input data look like? Well, it's spatial, it's 2-dimensional, it's not time dependent, it's a uniform resolution, it's a regular Cartesian grid structure, and it's a vector data. It's vectors. This is what it looks like. So if you want to see what it looks like, this is an image from the paper. I just looked through the paper, I found an image that I thought was a nice representation, and I put it in there. So we've taken this really big, complicated research paper, and we've compressed it down to 1 slide. And we extracted the essentials of that research paper. Right, that's the idea. So those are 4 essentials. You could add some other essentials. This is a kind of recommendation of the essentials, but you could modify this. If you have a special project you're working on, a special kind of literature review, you might add some other ingredients that you think are really important. Like analysis techniques. What basic analysis techniques are used? Is it statistical methods, visual analysis, software tools? That could be something. This is important, the evaluation techniques. How is the research being evaluated? For example, measuring performance time, human-computer interaction experiment, or a case study. That's important information. That is part of coursework 1. Questions so far? So Zach, I hope you're going to like this next slide. It's just for you. Evaluation techniques. This is a really difficult part of computer science. This whole evaluation business is what makes computer science difficult. It's one of the things that makes computer science difficult. So here are 3, not the only 3, but 3 very popular evaluation strategies to to demonstrate to the world that what you've done is a contribution. You can perform a software performance-based evaluation. What does that mean? That means you've made some software and you believe you're trying to tell the world that what you've done is better than somebody else. How is it better? You have to compare your software with some previous software, right? So is the new software faster? Are you doing something that achieves a faster result? Is it more accurate, right? In AI, there's this huge kind of theme of accuracy, right? How accurate is your facial recognition? Or how accurate is your object recognition, right? It might be more memory efficient, like some algorithms, if you look carefully, they take up a huge amount of memory. Maybe you've done something that takes less memory, takes less hardware resources. It could be a human-centered evaluation, so that means I have a piece of software that I think people will like more than some previous solution. Like, it's going to be more user-friendly. Like, people will be able to accomplish their work more quickly, for example, using this software. Or they're going to be happier, not so frustrated than the previous solution, right? Is a user study conducted? Are there a general set of users given tasks to complete? Like, okay, here's my software, now here are the tasks you need to complete. And then I'm going to time you to see how quickly you can complete these tasks. And then I'm going to ask you, did you like your experience, or did you hate your experience? Was it frustrating, and so on? There could be a set of expert users asked to evaluate the software. In other words, the software is specifically for an expert, like a doctor. Could be a doctor, could be an engineer, could be a biologist, a psychologist. And an expert is trying to use your software and evaluate it. It's not the general populace. It's not an ATM machine, but it's some very specific piece of software, like an ultrasound interface, for example. And then this is where the results, by the way, Zach would be mentioned, the results. And then application-centered or case study evaluation. That means the software or whatever it is you're producing is demonstrated on a special problem. Like, now I'm going to demonstrate how I can analyze the entire surface of the planet using my software, and then that's a special case where the entire surface of the planet is analyzed with this software. Right? It doesn't necessarily involve a performance comparison or a special user study. It's a special case, a special application for a very specific purpose. Yeah. So evaluation techniques usually fall into these categories. Not all, but let's say 90, at least 90%. Yeah, there'll be some exceptions. And then you'll be looking at a research paper thinking, how does the evaluation work? Which category does it fit into? That's part of the skill. That's part of the skill set that you are developing, right? Okay, here's another example. Extracting the essentials of a computer science research paper, example 2. The title is called P-Light, a study of parallel coordinate plot literacy. This paper contributes both pedagogical software and a literacy test for parallel coordinates plots. So it's a one-sentence summary of the concept, right? And it's using that word contribute, right? The implementation is just in one sentence, it looks like. The software uses linked views of scatter plots and parallel coordinates plots, and the test is done using an online tool called Qualtrics used to conduct the user study. So look, the evaluation is already mentioned in here. There's a correlated work, right? There's a previous user study that it builds on. Here are the input data characteristics. It's abstract data, it's steady data, the resolution, this is not relevant, the grid structure, multivariate. So in this case, a user study was performed. So the software was tested on users, general users, and evaluated. So that's, again, taking a 10-page complicated research paper, extracting the essentials, and putting it on one slide. Now, I haven't shown you really exactly how to do this. We're going to talk more about that on Friday. Right? On Friday, I'm going to take a research paper, I'm going to start looking through it, and I'm going to say, oh, here's the essential I need. Grab it, here's the essential I need, grab it, and fill in the template. Okay, this is another example. We're out of time, but that's another example. And there's a little note here about breadth versus depth. So we're focusing on breadth right now. In other words, we're trying to get an overview of a subject. We're trying to get an overview right now, right? We're trying to build that overview up. We're trying to look at multiple research papers and build up an overview so we can see and look down on a subject. Okay, any questions? It's very challenging. This is challenging. It's not easy. I'm not going to advertise this as easy. But it's a great skill to have. It's a great skill. Okay, we'll stop there. If there are any questions, you can ask after the lecture. Yeah, you're free to go.